There we are. So you can carry on eating. Because for some reason you didn't want to eat your lunch downstairs today, but who knows why. If you feel like it now, that's fine. It's there for you. And while you're doing that, we can also have a little bit of a chat. Oh, thank you. Because I wanted to talk to you about your epilepsy. And about what we're doing at the moment to try to reduce your seizures. So we're trying to reduce seizures, and the way that we're doing it is by listening to Mozart. And I wanted to just explain to you a bit more about what we're doing and why we're doing it. Yes. So let's see how good your pointing is today. First of all, let's just spell epilepsy. E-P-I-L-E, and for the P, P-S-Y, yes, epilepsy. And epilepsy causes you to have seizures, and you've been having very frequent seizures. We had a really bad spell, didn't we, where you were having them every single day and having them overnight, and it was really badly affecting your skills. The thing that we're trying at the moment is listening to who? M-O-Z, very good, M-O-Z. A, R and T, yes, Mozart. Just out of interest, quickly before we start on all the whys and wherefores, do you like that Mozart music that we're listening to? Why? E, yes. Okay. Do you like it? Well, it's a good job you do, because we've been playing it quite a lot, haven't we? And we've actually been playing it regularly to you since I think it was 27th of June. And we've been doing it quite I say quite randomly, we've been trying to play it every day, and we've been doing it a few times a day, and that was as a result of a little study that I'd seen. But we have noticed a significant reduction in your seizures, so we feel that it must be having some impact. So I thought it would be good just to spend some time giving you the background, a little bit more information about, you know, the whys and the wherefores, and some of the trials and studies that have taken place. I found it really quite interesting. So I'd like to talk to you, because we might try another trial of listening to Mozart overnight, and this was based on a trial that was done, a study that was done in 2012. So in 2012 there was a study in South Carolina, and it was done at a residential home. In a residential home, and the home was for people with neurological impairments, and many of them had epilepsy. So the study was done in a RESIDENTIAL, a residential, H, touch the O, there it is, O, go for the H again, H, I'll give you feedback, now the O, M and E. Why would that be a good place to do this piece of research using a residential home? Why? O, let me just get you in a better position. O, N, on, A, D, A, Y, on a day, T, O, T, O, D, A, T, did you want a Y? Touch the A again, A, and then Y. I thought it might have been. So, Y residential home, on a day, to day. Come on. B, A, S, I, S on a day-to-day basis. I, T, it, W, O, U, L, D on a day-to-day basis. It would. B, E, E, yes, A, S, after the S, it would be easy, yes, T and O, yes, M, O, N, yes, very nice. I, after the I, T, O, and R, yes, on a day-to-day basis, it would be easy to monitor. Yes, you could, if people were all living in separate homes, you'd be reliant on the parents and people monitoring it all, but if everyone's all living in the same place, it's an ideal place really to do this sort of research study, because you can make sure that everything is done sort of the same, can't you? So that was good. So this study from 2012 was actually a 3-year study, so it was quite a long time. And what they did, year 1, they measured baseline seizure rates. So what would that tell them? H, O, W, how, M, A, N, Y, how many, S, I, E, I, that was a Y, Z, that was good, U, after the U, R, then E, and then S. That will do, yeah, that the baseline would tell them how many seizures were happening without any sort of intervention really. How many seizures over the whole of a year. So that was year 1. Then year 2, they split the residents into 2 groups. Group 1 was we'll call it the treatment group, and group 2 was the control group. If you were in the control group, what would happen to you? If you were in a control group for a scientific experiment, what would happen? N, no, T, R, E, A, T, M, E, N, T. Yes, the control group would have no treatment or none of the sort of new treatment. Basically, they'd just carry on having exactly what treatments they were having previously. So, for example, if they were taking seizure medications, they'd carry on taking them. And actually in the treatment group, they would carry on taking any medications they were taking, so everything was exactly the same, except for the new treatment, which was going to be the music stimulus. So, the treatment group were exposed to specific music being played while they were asleep. And it was played at regular intervals right the way throughout the night. Right. So the specific music, what was it? The specific music was the one that we've been playing to you. It was Mozart, and it was the Mozart. Why are you standing? Sit down. Sonata. I'll write it down when you have a stand. For 2 pianos. And it was. Let me just find it. I have to write it down. Yes. In D Major. And it was K448, and the particular one that they used in this study was one, let me see, because I downloaded it on my phone, we can have a look. Hang on. Sit down. Was by, here, let's have a little look. Oh, I'm playing it all over. Right, we're not going to play it right now. Sorry, Chris, I'm getting a bit. How do I stop it? Would you know what? We could leave it playing in the background. There we are. Sit down. This one was this particular, I say version. It was just who was playing it. It was one by Andrei Prebin and someone else. I can't remember who. So that's the particular one that they used in this study. And because they'd used that one in this study, I decided that we'd use this particular one with you as well. So, what happened? Oh yes, so we've got year 1, year 2 was the treatment year. Then year 3, guess what they did in year 3? What do you think they might have done for the final year? Year 1, okay, go on then. SD wouldn't make sense. Did you want the D or the E? SE. Use a pencil, see if that's easier. I. You seem to be struggling. Is it Z that you wanted for seizures? Touch the I again. I. Let's do seizure. S, E, I. All the way down to the Z. You're finding it hard to go from I to Z. I, all the way to Z. It's interesting, you don't see I. Now touch Z. Z, that's better. Your, U-R-E. U-R-E. So in the 3rd year, the seizure rates were measured. Let's just do measure. M, E, A, S, U, R, all up to the E. Yeah, so the seizure in year 3, we'll just put seizure rates. We'll measure it again. And they stopped the treatment. They just listened. Sorry, they just listened. I'm listening to this. They just measured the number of seizures. Now, what happened was, during the treatment year, the people in the treatment group their seizures reduced by 24%. And then even in year 3, that the reduction was continued, it was by 33%. Would you say that was significant? Yes or no? Y, E. Yes, so you can see that's why I'm keen to give this a try with you, because we can see that already by just playing this a few times a day during the day we're having some success. But now if we have another go maybe at doing some overnight as well, as long as it doesn't disturb our sleep, we may find that that might even lead to more reductions. So let's just talk a little bit about the whys and stuff about epilepsy and why this particular stimulus might help. So listen, studies have shown that brain stimulation can induce seizures in people who are kind of predisposed to it. And some stimuli can provoke seizures which may be kind of learned. So once you almost learn to have a seizure when certain things happen. So brain stimulation can INDUCE. Yeah, brain stimulation can induce seizures. I wonder if you remember, because when you first started having seizures, certain things I used to think seemed to trigger them. I don't know if you can remember anything about that. Although the doctors didn't really agree with me. It was just an observation I had. Could you remember when you first started whether anything induced them? Use your finger. M-N-O-T. I'm not. Ooh. Get that bit out. So I'm just asking if you remember anything about that. And you said, I'm not. Go on. S-U. Go on, push. Oh, I'm not sure. Oh, that's all right. Well, I remember when you used to watch certain things on the computer. Your first few seizures happened when you were actually watching the computer, and you used to get a bit sort of mesmerised by them, like the intro to certain programs and stuff, and it seemed to be particularly when there was like blue lights on them, although the doctors they said that you weren't photosensitive, which means some people do have seizures that are brought on by flickering lights and things like that. That's why on the news often they always on television programs they give a warning if there's going to be flickering lights, because people who are prone to those sorts of seizures could end up having a seizure just from watching it. So anyway, so listen. So if there's some types of brain stimulation which may induce seizures, the opposite of that would be what? The opposite of that would be I M U L A T I O, stimulation. T, touch the T again. T, then well, stimulation. T, H, A, T, H, A, stimulation. That. P, R, E, B, E, N, T, S, S, E, I. Very nice. This is good practice. S-E-I. Now go back to that Z. That was the hard one you found before. Go touch it. Go on. That's the Y. Z, U, R, E, and touch the S. Yes. So the opposite would be stimulation. This is good. That prevents seizures. So this is what the scientists are studying. So, where are we? They have found, researchers have found evidence of non-invasive stimulation of the cortex by patterned external stimuli may reduce, prevent, and terminate seizure activity in many individuals. So let's just take some of that. So the evidence is non-invasive stimulation. What do we mean by non-invasive? N-O-T, not, give me an example. Not A, N, on, an, O, very nice, O, P, E, R, yes, A, T, I, and O, and N, not an operation, yes, so that would be non-invasive, so it's not like an operation where they do a big piece of brain surgery or they make an implant of some sort. It's just totally non-invasive and stimulation of the cortex. Cortex. Do you know what? Just for the sake of it, for something different, we might like to try and write that word. It's a short word. Cortex. C-O-R-T-E-X. Let's just have a go. C-O-R-T-E-X. Pencil. See how good your handwriting is. Hold it nicely. So the C. Oh, lovely. And then O. O, that's the circle, remember? All the way around for the O. Make it a circle. O, lovely. Then the R is down and back up again. Down. Oh, that's all right. That was a big one. T is just straight down and across. T. Now, don't lose concentration. And across. Now, we've got to fit an E and X in here because you've gone quite big. E. E. Sometimes you're writing. Some days your writing is really small and neat, and sometimes it goes really big. E. That looks like an E. And then we want the X is just 2 lines. X. And X, that's it, cortex. Now, here we are. Where's it gone? Let's have a look. Here's a picture of the brain. Look, there. Can you touch the nose? There's the nose. There. That's it. So if you imagine that's your skull, here we are, there's your nose, and there's your skull, so that's the front and that's the back. So at the front we have, if you look, it's labelled frontal lobe. Frontal lobe, look. And just at the bottom of the frontal lobe there's the olfactory bulb. Ooh. And that's kind of, look, if you sit, it gives you a clue what that one's for. It's situated, look at that, sort of almost above the nose, so inside your head, somewhere in there. Okay, so what might that part help you to do? What might that part of the brain help with, the olfactory part? That might help with your sense of S. Go on, you're right. It's by your nose. S. Go on. Your sense of M, E, L. Yeah. So that one would be to help with your sense of, write it on, smell. Okay, so the frontal lobe is there. Let's have a look at some of the others. Temporal lobe. See, it's in green there. I know. Touch the temporal lobe. Occipital lobe is there in pink at the back, and parietal lobe is there in orange. All the different parts of the brain. Now listen. So when I was reading these studies, it said studies show that the cortical activity caused by certain music can cause activation of the cortical areas, and the Mozart music is particularly the prefrontal cortex. That would be here, there's a frontal lobe, prefrontal cortex will be there, do a cross. Oh, I haven't, that's not labelled on this one, the inferotemporal. I'll have to have a look. There's the temporal there, so I think it must be there in between the two. The occipital, touch the occipital at the back there. That's right, let's put a cross on that one. And the parietal lobe, find the parietal lobe. That's right, that's the parietal lobe. So, all of these areas are going to be activated. So it's quite interesting, isn't it, that just the music, listening to the music can activate all of those areas. So there have been various studies that have been done, not just the one that we're talking about over the 3 years, but there was one. Listen, there was one that was done with 29 students. And this was simply listening once a day to 6 minutes of Mozart. Once a day to 6 minutes of this particular sonata, and that showed a significant decreases in epileptiform discharges in 23 out of 29. So that's good. Okay, another study, Lahiri and Duncan. This was exposure over 3 months. Oh, sorry, I think that first one was 3 months as well. So another study over 3 months, listening for 45 minutes a day this time. In many, I don't know what the exact number is, but showed a cessation of generalised tonic-clonic seizures, so stopping of those seizures. That was good. Another one showed a reduction in discharges and seizures in both neurotypical and people with profound learning difficulties when they had a regular exposure over 6 months. And here was the recent one that got my attention and then got me researching it. I'm going to just read it to you because I think it's quite easy to understand. Sit down and let's read through this one together, and you might be able to read some of this with me. So let's start with the headline and you can follow it. The Mozart effect shown to reduce epileptic brain activity new research reveals. Do you know what's not really new, is it? I'll read this bit. Music by Mozart has been shown to have anti-epileptic effect on the brain and may be a possible treatment to prevent epileptic seizures, according to new research presented at the 7th Congress of the European Academy of Neurology. So this was presented, look, what day? You could say that. Saturday, the 19th of June. That was Dad's birthday. So on Dad's birthday, this research was presented. Music by Mozart has been shown to have an anti-epileptic effect on the brain. Researchers believe that the acoustic properties within the music are responsible for the effect. So they believe the what? A C O U S T I and must be C. Show the acoustic properties. Let me just put, there we are. Listening to the Sonata for 2 pianos K448 led to a 32% reduction in epileptiform discharges. These are electrical brainwaves associated with epilepsy and can cause seizures or bursts of electrical activity that temporarily affect how the brain works. So the reduction was how many? How many percent? 3 and 2, yeah, 32%, which is very significant. Now listen to this. Team, which was led by Professor Ivan Rektor from the Epilepsy Centre in the Czech Republic, compared the effects of listening to Mozart's Sonata for 2 pianos K448 with Haydn's Symphony No. 94. Right? The effect on brain activity were measured by electrodes that had been implanted in the brains of epileptic patients prior to surgery. To our surprise, there were significant differences between the effects of listening to the Mozart and Haydn. Mozart led to a 32% decrease in epileptic discharges, but the Haydn's No. 94 caused a 45% increase. So it's really important that you just think, oh, classical music is good. But you don't just think that, but you only use particular types which have been studied. So that was interesting. When they tried to explain the Mozart effect, they found that men and women responded differently to the 2 pieces of music. So it's interesting. Listening to Haydn's music did lead to suppressed epileptiform discharges, but only in women. In the men, there was an increase in the discharges. So, the properties such as rhythm, dynamics and tone showed that the acoustic features of music composition have a different effect on men and women. We believe that the physical acoustic features of the Mozart music affect brain oscillations, which are responsible for reducing epileptic discharges. So they believe it affects brain, what was the word that they used? Oscillation. Come on, it's a long word. Alright, I've got a bit of headache. Go on. S C I L L A T I O. And an oscillation is just kind of a movement really in the brain. Let's just go in, right? They previously hypothesised that the Mozart effect was connected to the emotional effects of music, such as dopamine being released because you enjoyed it when you listened to music, but there's no proof of this mechanism. We found the reduction was larger in the lateral temporal lobe. Dan, which is the part of the brain which participates in translating acoustic signals, rather than in the mesiotemporal limbic region, which plays an important role in the emotional response. We're nearly done. Yeah. So, the professor says the effects of listening to music on epilepsy cannot be explained by the effect of dopamine releasing. Our patients were not music connoisseurs and so were emotionally indifferent to the two pieces of music. Experts believe the study's findings could pave the way for individualised music therapies to prevent and control seizures in the future and have called for more research. I think that I'm going to keep a full log of what we're doing, and I'm going to report this information back to our neurologist so that he might like to try and recommend it to other patients. Now, I wanted to ask you a quick question though, because we've been playing this music to you quite a lot. So, are you feeling any different? Have you got any comments that you'd like to make about the effect that it's having? I am A D. Well, AD. Ooh, is that J? Touch it if it was J. Touch it again for me. J. U. S. Ooh, got the hiccups again. T. I. It's all right. I am just come on, see if you can finish it. N. I am adjusting. S. L. O. W. Slow. I am adjusting. S, L, O, W. Touch the W again. Touch that W. W. L. I'm adjusting slowly. T. 2. I am adjusting slowly. 2. Come on. Let me read. So how's listening to this music affecting you? I am adjusting slowly 2. This is really interesting. Oh, there it comes on again. T, H, E to the. What's that? To the what? R, E, D, U, C, I, N, G to the reducing, S, E, I think you need that Z again. Touch the I. No. I. Okay, wait a minute. So I am adjusting slowly to the reducing, and you did S, E, I. Just turn the volume down on this a little bit. Just finish this off because this will be really helpful. I'm sure the neurologist will ask me, how does Chris feel about this? Does he feel it's helping? So you put, I'm adjusting slowly to the reducing S, E, I. You're there. Touch the Z if you want to. You're down by then. Touch the Z. Super. SEIT won't make sense. But go on, carry on. U, R, E. Alright, I think you wanted the Z, but you just couldn't get down there. I'm going to put this air conditioner on because it's gone ever so hot in here. I am adjusting slowly to the reducing seizures. Now, come on, down you go. Because you're more accurate when you're sitting. I, T, F, E, E, L. It feels A, B, I, T. It feels a bit. This is good. Come on, it feels a bit what? S, T, R, A, N, G, E, A, T, T, I, A, T, T, I, M, E, O, S. It feels a bit strange at times. L, I, K, E, line, I, A, L, M, A, like I, A. Feels a bit strange at times, like I, L, A, B, I, T, it, C, O, N, C, O, N, C, O, N, F, U, S, E, D, B, U, T, but, I, A, M, H, A, so I am H, A, like I am a bit confused, but I am H, A, touch the A again, A, P, Y, maybe you wanted happy, yeah, happy, T, O, but I'm happy too, is that B, E, T, R, Y, I think that was, I, N, after the N, G, happy to be trying, T, H, I, S. Okay, but I am happy to be trying this. you wanted to say, or is that finished? Oh, hang on. Is there any more that you wanted to say about this, or is that finished?
No.
Oh, okay, go on then. R E A L L. Really? Was that X or W? W? Yeah? Was it W? Touch it again if it was. Really? W O Really? W O. Go on. N D E R. Really? Wonder. W H Y. Really? Wonder. Y. M O R E. More. D O N. After the N, don't. D O T H I and THI. This. Really wonder why. More. Don't do this. Okay. Yeah, it's interesting to me as well. It just seems like such a simple, no harm thing to try, doesn't it? I want to just before we finish, just come down. I just want to read this little bit too, just to finish off. It's interesting because not only does listening to this help with seizure activity, it's suggested that exposure to this specific music has been reported to evoke short-term persistent activity in networks and cortical areas overlapping with those implicated with working memory, and to enhance or prime spatiotemporal reasoning ability. Oh, particularly strong activation of the dorsolateral prefrontal cortex has been consistently reported to occur from the stimulation, which is an area critical in working memory, along with an area possessing afferent and efferent connections with essentially the entire cortex. Goodness me. So it looks like it's beneficial from numerous studies to show that music stimulation extends beyond auditory cortex and involves a widely distributed neuronal network. Very good. Okay, so, alright, we'll finish it for now. You did really well, and we'll do a little bit of reading of that novel that we've started. Thanks, Chris. Let me just turn this off.